Assalamu alaikum. This is Sayyid Nail from Artificial Intelligence, Lecture 1, Section 1 with Dr. Sayyid Saleh Raza, and from CS351. And we're gonna basically be doing a brief review of Module 1 for my class participation grades in whatever we've learned in the Artificial Intelligence class up till now. So, starting off in week 1, we did a basic overview of the syllabus, did a course intro, learned a bit about agents, and we delved into it at first, starting off with a brief history of AI. We studied what artificial intelligence really is, in which it's basically the science and engineering of making intelligent machines, especially intelligent computer programs. And then we defined quite a few things like what is intelligence, strong AI, weak AI, etc., etc., and essentially what the whole goal of artificial intelligence is, how far artificial intelligence might take us. We studied the Turing test, which Alan Turing basically wrote an article in which he talked about the conditions needed to basically consider whether a machine is intelligent or it isn't. So basically, his whole premise was that if the machine fools the human observer into thinking that the machine is a human, then the machine is intelligent. So, well, that was just the really start of it. So we moved on from there, and we started up with the problem solving part of the module, in which we started studying about intelligent searches and unintelligent searches, in which unintelligent searches were ones which do not have heuristics, right? So the ones which are essentially exhaustive searches, which you might perform on, for example, in the lectures we performed it on trees, right? Which were essentially of games like the eight puzzle game and the frog game. Though I don't think we did that in class, but the eight puzzle game we did, and essentially breadth first search was what Mrs. Saleh said was the best way to find to get to a solution, the fastest way. But even then, a breadth first search or a depth first search, for that matter, is an exhaustive search. And then we essentially started learning about intelligent searches. What are intelligent searches? They're basically ones which use heuristics essentially. And then the question might arise that, hey, what is heuristic? So it's essentially an informed way in which we use additional information to guide how we're gonna proceed with our program and pick the best next step. For example, in the next as the next state. Um, Basically, for example, in the eight puzzle program, all we did is we used um, basic knowledge about how what our goal state should be to figure out what the to figure out whether we're proceeding the way that we are through our search to a particular to the correct solution or not. So it just helps solve the problem faster, and that's essentially what makes it intelligent. And we use a heuristic evaluation function for that. Oops. Well, the electricity just went in my house. I'm not too sure if I'm visible anymore. Well, hold on. Just turn on the generator. Well, I mean, something's better than nothing. I'm just gonna proceed because I don't know when the electricity is gonna be back, and normally it goes for a long time when it does. Anywho, where was I? Heuristic functions, right? So, I mean, we studied about heuristics and the basic ideas behind heuristic searches, yada yada yada, and then we got to A star algorithms, and we did a basic introduction of them. What is a star algorithm? It's essentially a graph search algorithm, um, which works when the map is essentially represented as a graph. It's one of the most popular choices for a graph search algorithm. Um, um, so yeah. Okay. No. Sorry about that. I just got a bit threw off by the electricity leaving. Right. So and then we studied search and optimization problems. Right. So what are search and optimization problems? We basically studied two forms. One which is hill climbing, and the other one is simulated annealing. So, what the question might be? What is optimization? So, optimization is uh, essentially like we use optimization to we're basically using simulating annealing and hill climbing to essentially optimize or find a global optima in a particular problem. So, for example, in hill climbing, we essentially start wherever using any x or y value. For example, if we're evaluating a mathematical function, we want to find the z value. We're using x and y values. We choose any random x y value within a range, and uh, anywho, and then we evaluate the z answer from it. And then what we do is essentially um, we basically try to find the best next values for x and y. We try to modify them a bit uh, close by, and if they are if the z value is better, then we move on to that neighbor. Otherwise, we just stick with our own current value and essentially just quit the program. But the problem with there are problems with hill climbing. Hill climbing is very short-sighted, and simulated annealing is essentially what solves that problem. The name comes from metallurgy. It's essentially in simulated annealing. Uh, we try to the problem with hill climbing essentially is that we get stuck at local maximas because of that, because we're sorry, we get stuck at local maximas. Uh, right? So because we just look at the neighbors and then we just quit essentially. Um, um, so simulated annealing essentially what it does is that it employs a random search which it accepts obviously accepts increases in the global optima, right, which might help us get to a greater value, but it also accepts based on some probabilities, random probabilities. It also accepts decreases within the within our z values, which would somehow let it escape a local maxima and get to a global optima, a global maxima. Sorry, global optima. What does that even mean? Anyways, and it uses uh, the temperature probability function to essentially do that. Anywho, that was most of module one. At the end of it, we studied essentially game trees, uh, in which we basically represent two-player games through game trees. And other than that, we also studied the min-max algorithm, which is a useful method for simple two-player games, in which you can select the best possible move in a game in which one player makes a move and then the other player makes a move, like alternating moves. So essentially, for example, in a game of tic tac toe, you might use that. So I think that is it for module one, and I'm